Welcome. In this video I'm going to show you how you can perform a Freeman Tukey Goodness-of-Fit Test, or a modified version of it, using Python and my stikpetP library. If you don't want to use my library, you can see another video of mine where I'm not using my own library. The Python version I'm using is 3.11.5, and I'm using JupyterLab, but the code should work in any Python environment. I'm going to focus on how to obtain the output, not so much if you should be using this test, because there are quite a lot of different tests that could actually be used, and some might even consider this one to have become redundant. To show you how you can get the output, I'll first need some example data, so I'll load in pandas, and then I can use the read CSV file to load a file called GSS 2012, which is from the General Social Survey from 2012, slightly adjusted for some example purposes. I don't need all the data, I only need one nominal field, so I'm picking the marital status, and to quickly get an impression I use the value counts. And that gives me, for example, that 314 people selected the divorced option. Now, my library, it's not available directly. You need to install it via my GitHub account. So use pip install and then this link. And then you can import it just as any other library. The function of interest is, of course, the test TS Freeman Tukey Goodness-of-Fit. It has a few parameters. The first one is, of course, a must, the data itself, and the others are optional. The expected count, so you can provide it with specific expected counts. You can opt for a continuity correction, either Yates, Pearson, or Williams. And if you want the modified Freeman Tukey version, then that's also an option. Just set that to true. The function just takes the name of the function and then the data, that's the minimum, and it spits out a data frame with the sample size n, the number of categories k, the chi-square value, the statistic, the degrees of freedom, which is simply the number of categories minus 1, the p-value, also known sometimes referred to as significance, and this actually informs us the chance of having this kind of value, or even more extreme, if the assumption about the population would be true. I didn't give it any expected count, so it simply assumed that each category would have 1941 divided over 5 as their expected count. Because they're all the same, the minimum expected count is also 388.2. If this p-value is below a usual threshold of 0.05, we would reject the assumption and then conclude that there are significant differences. It also shows the percentage of cells that had an expected count below 5 and the test that was actually used. Alright, we could have also, like I mentioned, provided our own expected counts. So for example, if I had expected these, I can actually put those in a nice little dictionary, and then I can say, well, okay, what happens now? And in this case, as you can see, it's still significantly different. A quick showcase of all the other options. As you can see, there are quite a few different ones, and they all give the proper output. Alright, I have a separate video where I go over if you don't want to use my library, but for example SciPy or stats models, or even no libraries at all. Alright, and that was it. I hope this was helpful, and thank you for watching.